This is the Corollary 1 of Newton's Principia Mathematica. So Newton says a body by two forces conjoined will describe the diagonal of a parallelogram in the same time that it would describe the sides by those forces apart. So first of all, we don't need to think very complicated stuffs. Let's think very simply. All Newton is saying is that he is basically trying to create this diagonal. Just suppose that this point here is A, this point here is B, although this is not seen in this picture. So Newton is basically saying that when these two forces are acting, then we can create this diagonal AD. And so here let's read what Newton is saying. If a body in a given time by the force m impressed apart in the place A should with an uniform motion be carried from A to B, blah blah blah. So basically what he's saying is that let's apply two forces here. The first force is force m. M is a force which goes from A to B. When m is applied, then there is A to B, and when n, the force n is applied, then the movement is from A to C. So we have these two lines, and from these two lines, let's construct this parallelogram. So this AB is parallel to CD and AC is parallel to BD, and then we draw this diagonal. And here is we need to consider this particular line in here. Since the force N acts in the direction of the line AC, N acts in the direction of the line AC, which is this AC, which is parallel to BD. This force by the second law will not alter the velocity generated by the force m. So this force which acts from AC, this force N, will not alter, has nothing to do with the force m which is acting horizontally. Force m is acting horizontally, force n is acting horizontally, and Newton is saying that they are kind of separated. They do not influence each other. So and here Newton says so because of this reason which I just said right now, that which he says it in this line, since the force N acts in the direction of the line AC parallel to BD, this force by the second law will not alter the velocity generated by the force m which the body is carried towards the line BD. Since these two are separated, Newton says the body therefore will arrive at the line BD in the same time whether the force N will be impressed or not. So because of this reason, the body will arrive at the line BD, and the force N AC need not be applied. So no matter what happens, whether this force AC is applied or not, in both the cases there is no effect on time. The force when applied, it will not alter the time it takes to arrive at the line BD. So Newton is saying in both the cases, the time taken for this object to move here, whether this force N is applied or not, in both the cases they will be the same. And then Newton says, by the same argument, at the end of the same time it will be found somewhere in the line CD. So in the same way, the same is the case for the movement towards the line CD. So basically, if this force m is not applied, then whether this force m is applied or not, in both the cases it will take the same time for this object to arrive at this line CD. So Newton says by the same argument, at the end of the same time, it will be found somewhere in the line CD. Therefore, it will be found in the point D where both lines meet. Here he says, therefore, it will be found in a point D where both lines meet. But it will move in a right line from A to D by law 1. So, but it will move in a right line from A to D by law 1, which is basically the law of inertia. So Newton is saying that this body will move from A to D because of this reason. So let's recap. So what is the reason? Why does Newton say that when these two forces are applied, then this body will move from A to D? And the reason is because Newton has this law. Newton, with his intuition, has made this law, which here you can see this by the second law. It is written that this force N, when it acts upon this direction, then it has no influences upon the force M. So basically, when both M and N are applied together, then there must be a certain resultant. And basically Newton is saying that this when both of them are applied, then the resultant force will be AD.